Hi, welcome to this lesson on probability counting principles part 2. Let's have a look at question 1. Rajiv's wardrobe has 8 different pairs of shirts and 5 different pairs of jeans hanging on the rails. How many ways can the clothes be arranged if all the jeans must be next to each other and all the shirts must be next to each other? Okay, so here we have a restriction. The restriction being that all the jeans and all the shirts have to be next to each other. So I'm going to label the 8 shirts as follows, S1 up to S8. And then all the 5 jeans together we'll label as J1 up to J5. Okay, so these are considered different objects, so that's why I've labeled them as such. Now within each group, I can still rearrange the shirts in 8 factorial ways by the fundamental counting principle. And likewise here, I can organize those 5 jeans in 5 factorial ways. And then lastly, I can group these 2 objects in 2 factorial ways. So by the fundamental counting principle, this is 8 factorial times 2 factorial times 5 factorial. So let's go ahead and have a look how much that is. So it's going to be 8 factorial times 2 factorial times 5 factorial. So I get 9,676,800. 9,676,800. So quite a lot of ways, but that is kind of small compared to if I could arrange them in any way. And that is what this question is all about. How many ways can the clothes be arranged on the rail? So there's no specific order. So there are 13 objects altogether, 8 shirts and 5 jeans. And 13 factorial gives us a total amount. So let's double check what that is. 13 factorial. And you can see this is quite a huge number now. Now we're in the billions. Okay, so this is 6,227,020,800. 6,227,000. Okay, and 227 million, sorry, and 20,800. Okay, so quite a large number. See, you can space it out by 3s to get the magnitude of the number. Okay, so 6,227,020,800 different ways that we can arrange these items of clothing without any restrictions. So quite huge. So this number is quite small in comparison to that number because there's restrictions here. Lastly, what is the probability? So probability, remember, is a value between 0 and 1 inclusive of the clothing being arranged such that a shirt must be at the start of the rail and a pair of jeans must be at the end. So we're looking for the probability where it must be S at the start, so a shirt at the start, right, and jeans at the end. Okay, so how do I work out this probability? Well, it's the number of ways that I can do this. So if I call that star, it's the number of ways that star can happen divided by the total number of ways we can arrange those objects in any given order. But we actually worked out that number. That number was this number here, 6,227,020,800. Okay, so we just need to work out this number here and then we've got the probability. So how many ways can we arrange where the shirt must be at the start and the clothing the jeans must be at the end? So when you think about it, so there are 13 objects. Okay, 4, 8, 12, 13. There must be a shirt here at the end and a jeans here at the end. Well, how many shirts do I have to pick from? I've got 8 shirts that I can pick from. And how many jeans can I pick from? I have 5 jeans that I can pick from. All right, once I've picked one of those 8 shirts, I have 7 shirts left that I can arrange in any order. And once I've picked one of the 5 jeans, I've got 4 jeans left over that I can pick in any order. So this 7 plus 4 is 11 different ways, or 11 factorial different ways, I can arrange those 7 shirts and those 4 jeans. Okay, so by the fundamental counting principle, I multiply these outcomes and we'll get the following number. So I got 8 times 11 factorial times 5, and that's equal to 1,596,000,000. So 1,596,000,000 672 So at 1,596,672,000. Okay. So again, a very small number compared to the total number of ways. So therefore the probability is finding the ratio of these two numbers. Okay, so if I do this division, let's check what we will get. Okay, so let's bring up the calculator. So 1,596,672,000 divided by 6,227,020,800. And I get 10 over 39, which works out quite nice. So let's say to 2 decimal places, that's 0.26. Okay, so it's a roughly 26% chance that the clothing will be arranged such that a shirt is at the start and a jeans is at the end. So quarter of a chance, 1 in 4 times, you'll probably find that if you open your wardrobe right now. So if you go and open your own wardrobe right now, is there a shirt at the start of your rail and a jeans or long pants at the end of your rail? Okay, there might be a 25%, 26% chance that that is the case. Okay, if you have shirts and jeans on your rails. Okay, that's how we would do this type of question. I'll see you in the next one.